Good morning, Scott here, known as Cantaloupe to some online, and I'm bringing a video to you on a subject that's interesting to me. It might be of interest to you or someone you know. And I'm going to get into something a little bit technical in this video, but I'll keep it short and to the point. It's a brief overview of quantum physics with some special emphasis on practical applications, modern practical applications based on what I've read, and I'm going to get right into it. So it has been predicted by researchers and quantum physicists that there are many interesting and kind of spooky features to the science, that things that can happen that defy common conventional physics, that require a great deal of math and understanding, usually to control them and to explain what's going on. This has been known since about Albert Einstein's time, and a little bit before that they were getting into quantum physics and quantum mechanics. But I want to talk about what's going on at the Large Hadron Collider, the CERN laboratories. If you've heard of this place, there are ongoing experiments, quote unquote, that serve some very important purposes. So with that in mind, I want to get into some background, just a little bit of brief background about quantum teleportation, spooky action at a distance, which is what Einstein himself used to describe this effect, where you have something that is outside of the realm of space-time. Actually, it's a spooky action at a distance was predicted within Einstein's equations. At one point, he came across this possibility and described it as that, and it turns out that there's something called quantum entanglement, where you can pair subatomic particles or actual larger bodies of mass in a way that the effects are instantaneous. This contradicted Einstein's predictions, his original predictions of relativity, where he said that there was, due to relativity, no absolute simultaneity, which means no two events can be said to have occurred at the exact same time, because time is relative. Time is flexible between these events, and any kind of attempt to measure the simultaneity of two events would be flawed and subject to the restrictions and limitations of relativity itself, making the findings irrelevant. It's just you wouldn't be able to measure it, he said. So, however, he came across this thing I mentioned, which is quantum entanglement, which kind of threw a wrench into his equations, and he was starting to get into all this before he died, but never quite bridged the gap, didn't come up with a unified field theory, and the rest is history. But they have done a lot of research, to say the least, since then, and quantum entanglement is real. It's been proven many times in the laboratory. It continues to be proven and actually used for practical purposes. For example, you can, and this is famous news that has appeared, actually many years ago, that they were able to successfully create a miniature black hole in a laboratory by, combining proton beams, high energy particle beams, when they collide, can create a rip in the fabric of our space-time that creates a black hole, a miniature black hole, and they can sustain this thing indefinitely as long as there's powers to the system that's creating it. So this isn't science fiction. This is actually going on, and there are plenty of actual reputable articles and reports of this stuff. A lot of it is pretty lofty. It's it uses a lot of advanced math to understand it. So if you want to get into it, some math classes might be necessary. But this isn't about the details. It's about the overview, the big picture of what's going on with these miniature black holes that they create. So pause that idea just for a second. It turns out that when you create a miniature black hole, this is an interesting thing. You clone the universe that you're in. This is kind of mind-blowing, and they don't actually tell you this. They don't make it widely known, because it's a little bit disturbing even, that you can create a miniature replica of the entire body of space-time that is our universe. Our universe, turns out, is bound by an event horizon, and we've known this part for a long time. Our universe exists within a black hole in another universe. Some people still debate this, but it's pretty clear that when you create a miniature black hole, such as in a laboratory by combining high-energy proton beams, you create an exact replica, including all of its contents, including all of its space-time from beginning to end, in the laboratory. And there's a challenge, of course, in seeing what's inside of it, because you have what's called an event horizon, and it's, just because it's a miniature black hole doesn't exempt it from the problems of normal natural black holes, where you have what's called a Schwarzschild horizon. I might be mispronouncing it. I think it's Schwarzschild horizon. You have the point at which light, because it's a black hole, remember, light begins to orbit around it, outside of which light bends away, inside of which light bends inward because of the gravity, right? Because of the intense gravitational pull, light itself is pulled inward, and that's the point where something becomes a black hole if it can achieve this. But there's a problem. The point here is that there's a challenge in bridging the event horizon so that you can interact in some possible way with the inside of the black hole. And whether it's a natural one or an artificial one, makes no difference. You have the same challenge. So I don't have all of the specific details of what is involved in bridging that. I just know that it's been the subject of intense research for decades, and I'm quite sure that they've gotten to it by now. They figured it out. There's something called Hawking radiation, where particles will, on that horizon will split, where one, like I said, is entangled with the other one. One goes up, one goes down, so you see how it goes. But if they're entangled, remember, entanglement bridges space-time. Like I said, with quantum physics, you have this thing called entanglement, which isn't subject to distance, it isn't subject to anything. And with Hawking radiation, you have, if you concentrate a signal of some kind with the intended purpose of splitting it at the event horizon, one particle goes up, one particle goes inside, but they're still entangled, you have a means of communication. You have a means of probing the interior of your black hole. So this is a lot of this is theoretical, and a lot of it is also confidential and secret, but it's also deducible just by mathematics. If you know physics, astrophysics, if you know a little bit about quantum physics, it's not hard to put the puzzle together and see exactly what they're doing. So back to time travel. It might sound crazy, but it's not. It's not, because you're not actually traveling in time. You're not traveling in time in your universe. Here's the catch. You can potentially browse time in a miniature black hole, but being that it's a clone of your universe with some very, very minor quantum differences, 99.9999999% exact copy of your universe, you can pretty much bet that what you observe, if possible, in a miniature black hole will resemble exactly what's going on in your place, in your universe, if you can somehow observe it to begin with. If you can browse to that point, you can even potentially interact with it and affect change. Now, here's the really funny part. Here's the mind-blowing part. Consider that when you reach into a miniature universe, someone, due to the fractal nature of what's happening, is also reaching into your universe at the same time, doing the exact same thing. This gets really interesting. So if you want to affect change in your own universe, you just have to do it to the miniature black hole. And as if by magic, it happens in yours from your parent. If that makes sense. So this is some alien level technology, okay? It's alien level, and it's not the only alien tech that we have going around. If you've heard of crypto, blockchain, that some of this stuff was inspired by alien tech, and I don't want to get into all that, but yeah, no, there are major advances in technology that have been inspired by otherworldly things that, if you look at it objectively with that in mind, there's no other possibility. So last thing I'll say, I don't want to get into too much detail, but when you have this capability, something opens up where time itself becomes less of a barrier, less of a limitation, when you can somehow precisely and practically browse through the time of your own universe by way of reaching into a child universe, knowing that the parent universe is doing the same thing to you due to the fractal nature of what's happening in the big picture. You can affect change to your neighbor. You can affect change to your local situation. And there is only the limitation that it has to be plausibly deniable. Okay, so this is where it kind of, I'm not entirely clear about this part, but there are limitations. There are limitations where it has to be unprovable, or else it falls apart due to uncertainty. It can't be certain. and it becomes a very pointed and real limitation of the ability to make change via all this stuff that I described. There's a limitation, and that is it has to remain uncertain. If it is able to be observed in a conclusive, provable, measurable way, it becomes no longer subject to this type of technology for some reason. And I'm still learning, and a lot of this, I'll just qualify this entire video as being speculative and based on things that I've read. I don't have, any advanced quantum credentials or degrees, but I do know, I understand the concept, I understand the principles of it, and this is in fact going on. I see evidence daily of things happening, and I also believe that we're not the only ones doing this. In final conclusion, I believe that human beings are being introduced to this process, this technology, and this four-dimensional existence, this form of existence where you can have a say in what happens within a range, within a channel, so to speak. You can't just do anything, but you can make change for sure in your universe, across time, in the past, in the future. You can do a lot of great things, you can do a lot of evil things, and if you have seen some of this stuff, you know exactly what I'm talking about. This might fill some of those gaps if you're confused about what's happening. I think a lot of people are super confused right now, and my goal is to help people think that there might be some order to it, there might be some rules to it. It's not just, chaos and demons and angels and, people suffering. There's some sense to be made. There's order. Absolutely there is. And it makes a lot of sense when you understand it. And for obvious reasons, people don't necessarily want this to be common knowledge because it represents a power opportunity, right? And this is how humans like to view things, as power opportunities, to control their neighbors and their communities, to be the king of the hill, so to speak. And maybe the final lesson of all this is that some kind of gesture towards other people first is the only way it works. I'd like to think that the final lesson of all this is the golden rule, to come full circle to the fact that when you serve yourself before others, when you care more about yours and getting some than helping other people up a little bit within reason, there's only one way it works, and we already know this. It becomes religious. It really does become religious, because we've heard it before, haven't we? We've heard all this before. And it's funny how many things come full circle. But I go on and on, don't I? So reach out if you like with questions or comments down below. Thank you.